Hi. Welcome to the lecture on Chapter 3, at least the first of several lectures on Chapter 3. Out of all the chapters in this program, I think I found Chapter 3 only because the amount of detail and data that's thrown at you that becomes maybe a touch overwhelming, but I think between everything we've got provided here, it should help you. So this session will be on chapters, talk about IEEE Standard, amendments, all the different types of amendments they have, and it'll cover pages 61 to 81 in the textbook. This covers all of Chapter 3, all the exam standards. Don't worry about that. Now, the IEEE Development Standard is made up of IEEE standards are managed by what they call working groups. There are several different working groups. The two that we probably deal with the most are 802.3, which handles the Ethernet standards, and the 802.11 working group. Now, the working group oversees the creation, maintenance of the standard. So when a standard is first created, several drafts are generated. I mean, this committee looks at several different options, several different twists on what the standard should be. They provide each other feedback, investigate it, change it. And this is kind of called the drafting process. And this drafting process, when a final draft is finally agreed upon and approved, or ratified by everybody that's an active member of the working group, then it becomes a standard. Now, after a standard exists, otherwise known as ratified, you got to maintain it. You got to keep it up to date. And this figure kind of tells you what that process is. You got an original standard. As new technologies and ideas come together, they create a draft. This draft gets finalized as an amendment. The amendment gets put into place, and then once the amendment's approved, then it gets into an updated standard. So it's kind of a cool process, but when you have outside interests all trying to agree on what the standard should be, it does take a while to get to a consensus across all interested parties around the world to make sure that everything is covered. Now, the current standard, I guess I should have cleaned up that a little bit, is for 802.11, which is the wireless standard, is the latest one that's been ratified, is 802.11-2016. And it includes all historical amendments prior to its creation in 2016. Now, the amendment 802.11AH is not included in the standard, even though the timing is about right. But you will probably see it on the certification exam where it handles 802.11.2016 and the 802AH amendment. But this latest revision, either ratified or released on or about 2016, come into play. So just keep in mind, when we talk about the certification exam near the end of the semester, everything that's included in the 802.216 standard and the 802.AH. Now, one of your homework assignments is to start looking at the 802.11 standard. I've got a PDF in there, and you can take a look at it, and actually your homework will actually have you look at some of the aspects of the 802.11 standard. Now, what frequency bands are used in the 802.11 standard? Well, there's 4 general bands that are using. There's a sub 1 gigahertz band. There's the 2.4 and the 5 gigahertz, which definitely are used the most in wireless LANs, and then the 60 gigahertz channel. Now, when we talk about the 2.4 and 5.0 gigahertz, the 2.4 gigahertz range is from 2400 megahertz or 2.4 gigahertz to 2.5 gigahertz. Now, the actual usable range is 2.401 gigahertz to 2.495 gigahertz. Now, 5 gigahertz runs from 5 gigahertz to 5.83 gigahertz, and the actual usable standard is from 5.17 gigahertz to 5.835 gigahertz. Now, granted, not all regulating bodies utilize all the areas within those bands, but just know that those are some of the frequencies that are used. So keep that in mind. Now, this is where a lot of the homework and stuff is making sure you understand on the different frequencies that are available. Now, the oldest standard that's out there, physical standard, is 802.11. The 802.11 frequency actually introduced is the direct sequence spread spectrum, DSS. Now, as you can tell, there's, at least in these charts, you're seeing 4 different things that are important to remember. The channel width, how many spatial streams they have, what the data rate is, and which band they operate in. So if you look at the direct sequence spread spectrum, DSS, 3 S's, you got its channel width is 22 megahertz. It operates only at data rates of 1 or 2 megabits per second. It allows only 1 spatial stream, and it only operates in the 2.4 gigahertz band. Now, just keep in mind that, so that means if with a, and usually when you think about a channel, they usually use the center point of a frequency range. So if you're looking for the actual frequency, let's say of channel 1, it's, since we said what, the starting range is 2.401, then you add 11 to, because you got 22 divided by 2, would mean that the center frequency for frequency 1 or channel 1 is 2.412, and then either side. So that would be the range for channel 1. Now, if somebody says, gee, what is the frequency for the third channel? You want to make sure you do that same thing, but keep in mind, it's center frequencies, it's 22 wide, 11 before and 11 after the center point. But those are the 4 characteristics for each one of these centers. So on the high rate, look down here, we're doing the high rate DSSS. Now, it was released in the 802.11b amendment in 1999. It was introduced to introduce more advanced modulation techniques to allow data rates of 5.5 and 11 megabits, while still supporting the DSSS. I always have trouble with 3 S's. So it wanted to backward compatible to support the previous standard. So it wanted to make sure it supported 1 and 2 megabits, but then added 5 and 11. Now, it's still, to be able to make sure it still had that backward compatibility, it had to maintain the 22 megahertz channel width, still only had 1 spatial stream, and it still only worked in the 2.4 gigahertz band. Now, that's not always the case on everything. So, because if I look at the extended rate, the ERP up, the one in the upper right-hand corner there, that was introduced to bring in the OFDM modulation into the 2.4 gigahertz band. It was used in, now remember, OFDM was used in 802.11a. It was used for only 5 gigahertz, and it used 20 megahertz channel. So there are some differences, but don't worry about it for this certification. Now, but it does provide some of the basic fundamentals of OFDM that we talked about in the past that was implemented at the previous channel. Now, the high throughput one is actually, now it can operate both at 20 and 40 megahertz channels. It had up to 4 spatial streaming. Now it starts getting data rates up to 60 megahertz or 60 megabits per second. And it operated both the 2.4 and the 5 gigahertz frequency range. Now this is 802.11n. So as you can see, we're getting adjusting channel width. We're putting more spatial streams into place. We're increasing our data rates, and we're given a chance of operating both at a number of different levels of functionality. Whoops. Now, the OFDM signal here, you've got, it's the first to support 5 gigahertz. It was available in 802.11a back in 1999. It was a 5 gigahertz operation, but it was the first to use 20 megahertz, channels instead of the 22. Now, all the modern ones, all the newer ones, are all based on OFDM and use the 20 megahertz channels, or some factor, 20, 40, 80, 160, all on a 20 channel. Now, the 802A was the first to use the OFDM, and so its standard was actually named OFDM because it was the first, and that was a nice name to trigger it. I'm sure the committee had other reasons, but at least it's the first time that implemented this. Now, the high throughput, the HT standard, here it was introduced, like I said, is 802.11n. Offered several advantages over the older standards. It allowed 20 and 40 megahertz channel. An AP could offer a 40 megahertz channel and still serve as 20 megahertz channel. So I could actually have 2 running at the same time. So it was kind of very nice and flexible. Now the very high throughput, you got 20, 40, 80, 160 megahertz channel. It allows up to 8 spatial streams, data rates in almost 7 gigahertz range, but it only operates in the 5 gigahertz band. So it allows others now, even though 160 megahertz channels should not be used in an enterprise deployment, and I would highly recommend you not even use the 80 megahertz either, just because you don't have a lot of handsets that can utilize those. And with limited amount of frequency spectrum, it would be a very unique situation that you'd want to make sure you had that kind of speed with limiting how much spectrum you could use. But just keep in mind, you can have, up to 8 spatial streams. But I would keep it to, just using the 20 and 40 megahertz channel width. There's 2 others now that we talked about. You got the television, very high throughput, and it handles a little bit different. Now, luckily, the TV HT is not part of the certification. It's here for completeness sake. So know it exists. You won't be tested on it, but just be aware that it exists, and know that you get 4 spatial streams. So it's got a little bit slower range. And then you got the sub 1 gigahertz standard, sometimes called Wi-Fi Halo, HALOW. Now, it's designed to have long range, low data communications. And it was defined in 802.11ah. And it's great for Internet of Things. So industrial automation, monitoring networks. It operates at 1, 2, 4, 8, 16 megahertz channel widths. And it appears likely more devices will use the 1, 2, and 4 megahertz channels because likely use cases do not warrant the higher data rates. But you can see you're getting almost 350 megabits per second. So now you see that. So it's one reason we've got to include it here, because of Internet of Things being such a big deal. Now here is basically a summary of the important things, and what I would do is go along on each one of these, and I also identify which standard introduced these. So I'll leave that as an exercise for your studying ability. Now, so take a look at this. So this just summarizes all those 4 little charts, but that's the key information that I think you need to make sure you understand. Now, the question then becomes, how do we connect things to it? Now, in wireless, there are 2 different things. There's a basic service set, and basically that is devices, IEEE 802.11 devices that connect through a single access point. So as you've seen here, you see one AP and multiple devices that connect to it. That's a basic service set. If you see the term independent basic service set, all that means is we've set up a network without the use of an access point. Can't say that I've done too many of these. It's basically called an ad hoc number. You just let each other people know how you're connecting to it, and you can send it. You don't run across them very often. But we will be spending a lot of time on basic service set, because this is now where you get broadcasting the SSID, which is the name of the network or the access point. So just keep in mind that's the difference between the basic service set and the independent. It's the use of an access point. Now, there is one called an extended service set, which means I'm using access points, like in this case, 3 of them, but I'm having them connected on a shared Ethernet network. This is kind of how the campus is set up, where we've got probably 50 to 60 access points scattered through campus, and they're all connected together so that when you roam between H building and E building or F, you don't lose the signal strength. So we're kind of distributing the system so that I've got several basic service sets. APs are connected, and they usually run through a controller of some sort that can distribute changes and modifications throughout all of those access points. And you'll probably see that you'll call it a thin access point, which means there's really no controls at the access point, and they're only done at the controller. That's distributing all this stuff. And then there are a series of amendments that are important. They were ratified, and they may be on the exam only because of the key information that they brought to the table. like the 802.11i, introduced security to overcome weaknesses in the original security protocols that were put out in the 802.11 1997 protocol. That original security was WEP, W-E-P, and it was definitely too weak, and it was replaced by the 802.11i protocol, which introduced Wi-Fi Alliance certifications, WPA and WPA2. So those are keys that you want to remember that. So you don't make sure you don't want to use WEP. You want to make sure you use WPA or WPA2. That means you're using the 802.11i 2004 standard. Now the 802.11e 2005 introduced probabilistic quality of service, which allowed us to change priority of traffic based on the application that was being run. So streaming videos and things of that nature, now we can adjust priorities on those. The 802.11k-2008 provided radio resource management for a wireless LAN. So it allows me to now better understand automated power management decisions could be made. The 802.11r-2008 introduced protocols to secure roaming from one AP to another. So most of the APs today support that protocol. Now, 802.11w made additional modifications to security weakness not addressed by 802.11i, which 802.11i had a potential for denial of service attacks through the management frame manipulation. Well, in the 802.11w protocol, the management frame protection, MFP, was introduced, which made it harder to get access to deauthenticate and disassociate a valid station from a network. And then you got the 802.11u standard, which provided enhancements in the area of internetworking with external networks. Enhanced network discovery was made available. So it allowed some primary enhancements to utilize the Wi-Fi Alliance passport certification process. So a lot of information, a lot of little itty bitty details to take in. So study those charts, the summary table. Make sure you look at my mind map. I think I've got a lot of that stuff laid out there, which may help you. So I hope that this helps you with this material. And if not, you know how to get a hold of me. Have a nice day. Bye-bye.